Hi, C. Bubek Baji. This is my unknown Spectra assignment. I can't really. It's. I know it's the picture is zoomed in, so I could only just explain, and I have the actual document sent. So yeah. So based off what you see, it is clear that from the 1H NMR spectrum, that it does not contain aromatic protons in the molecule due to absence of signal chemical shifts from the 8 to 6 range. It is also clear that from the 1H NMR spectrum that the chemical shift from 4.5 to 1, it peaks in the splitting patterns, which is a certain aliphatic hydrocarbons. The chemical shift from 0.90 CERN from aliphatic group with integration of 3 protons with splitting patterns triplet indicated that neighboring should contain a 2 number of protons. So the chemical shift of 1.30 ppm is CERN for aliphatic group with the integration of 3 protons with splitting patterns triplet indicated that neighboring should contain 2 number of protons. The chemical shift from 1.80 a CERN for group with integration of 2 protons with splitting pattern sextet indicated that neighboring should contain 5 protons, a 5 number of protons. The chemical shift of 2.30 a CERN for group with integration of 2 protons with splitting patterns triplet indicated that neighboring should contain 2 number of protons. So pretty much just explaining the number of protons for the 1H. Also for the IR characteristics, the stretching frequencies are all functional groups. So one of them was a carbonyl ester. One of them was 2 of them were aliphatic, and then one of them was acyl and alkoxy. So for one of them was 1745, and one of them was 290, 280, sorry, 2980, 2940, and one of them was 1460, and one of them was 1200 to 1020 for the wave numbers. And just to say that the IR spectrum is generally useful for the identification of functional groups in an unknown compound based on the IR stretching frequency. On comparison of stretching/bending frequencies, one can identify functional groups in the unknown compound. In a given compound, aliphatic, carbonyl ester stretching frequency, and bending modes, aliphatic and ester are functional groups. 1H spectrum gives a rise to the x-axis chemical shift, and the y-axis is plotted relative intensity of different protons environments given to a rise to different peaks in the 1H NMR spectrum.